Hello and welcome to our lecture on simple Django models. Now, as you've seen in previous lectures, we talked about SQL, structured query language, and that's how we talk to databases, and it's beautiful because it allows portability up to a point across databases. And we talked about all the create table stuff, and so this is just a bit of review where we can type these commands to SQLite. We run SQLite, we run a create table statement, and we do it to say .tables, so we can ask kind of schema users. We did all this in a previous lecture, and so that's basically how SQL works. And here's a series of SQL commands from a previous lecture, just kind of as review. It's pretty simple, CRUD. Now, one of the problems is as I mentioned, is that different databases like Postgres and MySQL do all this stuff identical, but then some more subtle things like how foreign keys work, which we'll learn in a bit, or how they do limits, like pulling like 25, next 25, next 25. That's a little bit different. And so if you want to build an application that talks across more than one database, you got to think a little bit. And one solution to this, also to kind of limit the fancy SQL you have to learn, I like to say that you can learn the first 60% of SQL in about 3 hours, and the last 40% is literally a lifetime. And so advanced SQL is difficult to do. It's really hard to teach a class in advanced SQL. I can teach you advanced features, but then there are so many features that you just can't learn in a class because which database you're using, and they're different for every database. So one thing that's happened in the past decade or so is the emergence of what's called object relational mappers. And that is you have the physical database layer, and then you have SQL, which is an abstraction. It's an imperfect abstraction. And then Django builds another abstraction on top of that called object relational mappers. So we just create a Python object, and we ask that to be placed in the table. Now, the object may have a name and an email address and a birthday or something in it. It can have all kinds of data in that object, and then that maps into a name and an email address, and we have to tell it, like, do we want this to be indexed, and all these other kinds of things. We communicate through the ORM, so we leave the ORM alone. Now in Django, as we get more advanced, you can also sort of bypass the ORM because the way the objects are mapped into the tables is predictable. The names of the columns is predictable, and so it's kind of like it's a shortcut for. I like to think it's like the 80% of the most common things you do with a database are easily done with an object relational model, but object ORM. But ultimately, once you get to the more advanced things, you tend to not be able to do that with an ORM. You get to the point where writing the SQL is easier than using the ORM. But for about 80%, writing ORM code is way easier than writing the SQL. The other thing that ORM does is it allows you to have multiple databases because the ORM code inside of Django knows the difference between SQLite, Postgres, and MySQL. And so you could actually start an application that uses SQLite during all your development, and then when you deploy to production, you just go like, you know what, let's just use MySQL or Postgres instead. And that's quite cool. I find them limiting, and so I want you to know both how to use objects and how to use SQL, but understand that most of what you're going to do is to use the object relational mapping, and we get a lot of power with this. So if we look at sort of the way we communicate to the database, or the way we define the database, in SQL we create a table, and that right there is portable, but once you start doing things like adding auto increment columns and things like that, it stops being portable. And so that's the way we do it. But in Django, the way we do this is we have a file called models.py, and it's in the application folder. And then we are going to use object orientation. So we're going to, from Django.db, that's a package, we're going to import models. And models is now a class. And we're going to create a class called user. This is going to be equivalent to the name of the table. And we're going to, in the definition, we're going to extend models.model. And so there's a lot of, this is called extending, it's called inheritance. We're going to get a lot of features and functionality, excuse me. We're going to get a lot of features and functionality from this code. So there's probably 20,000 lines of fancy code that we didn't write that we're using. By extending models.model, we're getting all that. And then within here, we create a couple of attributes that basically says, give me a character field. Models is a class. Char field is a method within that class. Max length equals 128, and that gives us the name. These two things are equivalent. And what happens is when we build this, and we do what's called run a migration, then Django will make this table for us. But then we have this abstraction that we can use to talk to it. So this is called a migration, and so you have to be in the projects folder. And so once you create a migration inside of your Django application, then you go up into the Django project and you say Python 3 manage.py. Now manage.py is kind of like the thing that starts everything. So make migrations is actually creating files, because the idea with migrations is that you would debug your migrations like on your development environment, and then once you know, you would move them to production. So you'd make the migrations in development environment, you'd get them right, and then you'd like check them into GitHub perhaps. And then in production, you would pull your migrations out of GitHub, and then they'll migrate. So the make migrations bit, that is creating a set of migration scripts. And you can see that it's making these files, and they're actual files, and you can go find those files like 001 initial py. And then the migrate is reading the migrations and then actually changing the database. So that's the one where you might be able to make a migration, and it doesn't matter what database you're going to use. Could be your development in SQLite and production in MySQL. You would do migrate in both of those, and in your development it would make an SQLite database, and in your production it would make a MySQL database and put the tables in. And the SQL might even be quite subtle, and it will be subtly different between them, but you don't care. So migrate is the act of creating the database. Now in our development environments, we're going to be creating a file called db.sqlite3. And so if you get all messed up, you don't have to remake your migrations. They're just sitting there kind of as part of your source code. And you can like get rid of the db.sqlite3 file and then run the migrations again if you get kind of messed up. So the make migrations reads this and creates these other little files. You can take a look at them. They're kind of like Django's internal files. They're Python. It's just you're not going to write them by yourself. But then the migrate reads the 001 initial.py and then actually creates SQL commands and runs those SQL commands for us. And so if we jump after we've done this, we see this file db.sqlite3, and we can jump in and take a look. Again, you have to be in the right folder, so you'd be in the Django_projects and then the folder of the project, but there'd be a file called db.sqlite3, go into a Linux command line, type sqlite3, db.sqlite3, and you will find a whole bunch of things. And when you go into SQLite and you type .tables, you will see that Django has a bunch of migrations that are all there from the sessions and stuff we're going to learn how to use later, authorization, etc., etc. But then the particular data model that you created, which is a user data model, there's a table in there for that. And if we use the schema command of SQLite3 and we say, hey, what is in that user model _ user table? And you see a create statement, right? And so this is the actual create statement that the Django sent to SQLite to create the table. And I was talking about some of these things are quite predictable. The name of the column is quite predictable, ID, name, email, etc. It adds the ID field for you automatically. And most of it's portable, like this part here is quite portable, but this ID statement here, primary key auto increment, turns out that if you're in MySQL or Oracle or Postgres or SQLite, that's a little different, but literally the migrate takes care of all that because the migrate knows that thing, and as MySQL changes, that particular syntax doesn't change very much, but as MySQL changes, then the Django stuff changes and it all kind of works out. And so you can sort of run these commands and then sneak back into the database and you can see what they've done, but it's all very predictable. Don't want to spill my coffee on my computer. So You can also talk, you're talking at the low level when you run the SQLite command, but you can also be in that folder, same folder that has db.sqlite and manage.py, and then you can start what's called the shell. So this is different than the Linux shell, and you see the prompt change from $sign to three chevrons. And it's not the same as the Python shell, although it is the same as the Python shell with a whole bunch of Django libraries that are pre-mounted, okay? And so if you just say Python 3, you'll get this, but this next command that is from user model, models import user, that will fail unless you let manage.py start your shell, because again, it loads a bunch of objects and classes into your space, and then all of a sudden user model.models works, users there, etc. Okay, so this is pulling from your models.py file that you built, and so user model is the application name, and models is the models.py file. We import the user model, which is in this case a class. User is a class, and we're going to do a constructor call. And so we're going to say, let's make a new user, set the name to Kristen and the email to that email. And this actually has not done anything in the database. This creates, in effect, just a Python variable. And then to force it to be written to the database, we call u.save. And so save is a method on this new user object. Capital user is a class. We're using a constructor to construct from the class an actual instance, an object, and then we get that into u, the instance object, and then that object sits in our memory until we say save, and then it also pushes it back to the database. Now, one of the things that the save does, it assigns, in effect, a serial number or a row ID. If you look at these, they start pretty predictably at 1, 2, 3, 4, 5. But if you're getting a bunch of things coming in from a bunch of places, then the database just assigns each object, each row, and that's part of that whole auto increment thing. Come on, go back up. This whole auto increment thing that says, hey database, I'm going to put your records in, I'm going to give you the name and the email, and you come up with a number, but then when you're done, I want you to tell me what the number is. And this is how you get that number, by saying, oh, print u.id. Now if you printed u.id before you did the save, it wouldn't exist. And then print u.email, you can see this email is just the data we put in, but now this is not only in your u variable, but it's also in the database as well. Okay? Now, we can dig a little bit into how this object relational mapping is working. And so if you're in the middle, you're doing things like that last statement, you can from Django DB import connection and then ask connection.queries. And then what it does is it just shows you a little bit of debug data and what it did, how it started, the fact that it ran an insert statement. And again, this looks kind of familiar. This is it's making up SQL for you for that insert, the save statement, right? That save statement there. It's making that insert for you, and then you can actually see what it's doing, right? And so this save, set up a thing and save it. You don't need to know insert into or whatever, because the object relational model does it for you, right? And this is kind of what we did before, insert into capital users by hand. And so again, you'll find this ORM is going to save you a whole bunch of time for 80% of the things that you do with the database. And so you can do basic CRUD operations with this object relational mapper. The save is the insert. You can select is basically user object values. That's like select star, so give me all of the objects. A where clause is user objects filter, and there's your where clause. This is email is a column name, and c7@umich.edu is a value in that column. Values is actually go get them, so you can create kind of a query. So if you don't put values on, you get sort of a query that's not yet executed, and then values says go do it now. So you can do a different, you can delete something where you say, and so this is a little different syntax. This is kind of a selector that says these are the variables to select, and .delete says, the rows to select, and then delete those rows. So value says retrieve the rows, delete says get rid of the rows. And then you can, again, the same kind of thing. This is kind of like a where clause. User objects filter email equals c7@umich.edu .update, and then change this column in a way. and you can, go retrieve all the values. And there are things that correspond to lots of the SQL, like give me all these values, order by email, etc., etc., etc. So it's kind of a one-to-one mapping, and you will, again, you're going to do a lot of programming using this ORM in Django, and every once in a while you'll sneak down to SQL. And that's why I sort of teach you the SQL first. And there's lots and lots of fields that might not actually be represented exactly the same way in the database. So for example, an email field. Databases commonly don't have email fields. There might be some databases that have emails and others that don't. But because the object relational mapper is a layer between you and the database, and you say, I'd like this to be an email field, then it can add rules and stuff like validity checking, etc., to say, you know what, that doesn't look like an email address. And so there's all of these things, and these are very useful. And later we'll talk about connecting tables, and we'll use things like foreign keys and many-to-many fields and one-to-one fields, and those are less about the data and more about the connections between tables, which we'll talk in coming up soon. And so just to give you a sort of a bit of a sense of where you're at, this is our application, right? And so we have a browser on the left-hand side with a user doing some clicking. By now you may have created a urls.py file, and that takes the syntax of the GET request, /this, /that, /whatever, and routes it to a particular view coming from the views.py file. You may or may not have made one of those. Templates and forms help produce output, but the models are our interaction between us and the database. And so the actual code we write in Django can talk through the models to the database, which you may not have done yet, but this shell is talking through the Django models to the database as well. And if you're starting to use the admin user interface, the admin user interface talks to the database through the models, and it's informed by the kind of things that you add to admin.py. If you want to use the Django admin interface and have your model shown a particular way, it's got a bunch of defaults, but often you want to override those defaults, and so that's what you put in. And the model.py file informs this connection between the database, and it also sort of informs the kind of code you write here in a view code in Python or in the Python shell. That's kind of the Django shell, which is a Python shell with all that stuff added to it. Okay, so this model.py is critical to defining our relationship between all of our Python code and the admin user interface and the actual database. And so you'll see a recorded demo where I go through a bunch of those things, which I kind of just showed you. It's just actually doing it in a demo form, but it's all mostly in this lecture. And so the Django model is Django's version of an object relational mapper. You can write Python code after a while, especially if you have an IDE that can show you what objects have and stuff. It's a lot easier to write, whereas SQL, you have to know it and write it. You gain database portability. You can create these migrations to both build your initial schema in your database and then evolve that schema as your application evolves. That's one of the more valuable things. If you're building straight up SQL, going from like version 1 of your database to version 2 of your database, it is kind of frustrating and difficult. Sometimes migrating and evolving a database is harder than actually writing the SQL code in the first place. And Django gives you right out of the box this really cool administrator interface. The models.py and admin.py informs that. And later we're going to have all this automatic form generation. And so what we're doing here is it seems like we put like 3 lines of code into some file and then a whole bunch of magic happens. And that's really how Django works. And the idea is that way you as the developer can focus on the columns of your database and the forms that you want to put up and spend less and less time sort of manually building HTML that's very sort of brittle and SQL that's less brittle but still brittle. And so that's the idea. And so it's a little hard when you're getting started because the amount of code you write is so small and the amount of what that accomplishes is so great. But after a while, when you get all these little tiny pieces figured out, then all of a sudden you're like, okay, now I want to solve that end user's problem, and you can spend all your time solving that problem rather than just making databases and those kinds of things. So See you in the next lecture. Cheers.